All right, there are two simulations for you to try. One's called submarine. Hit that. You'll go into Edumedia. Now, I'll be using this same site going forward. You're going to have to log in, and the login is included with in the classroom, Google Classroom. It's COVID-19 for the username, and the login is Edumedia. Just type those in there, and then you'll be able to continue with these simulations. Otherwise, they give you like 10 seconds, 15 seconds, and they cut you off. All right, so for the submarine, you get to see how these things work with the air and water ballast to sink or float. And again, I can't write on the screen, so you just have to take this auto, through my words here. But you can fill the submarine with water by pressing over and get some water into the submarine. It starts to sink a little bit. And then what you can observe then are the numbers in the middle of the screen above the submarine. It has the mass of the displaced water and the mass of the submarine. And right now they're equal, and it's actually still floating a little bit of the submarine above the water. But then you can add more water, increasing the mass, and you can get it to go a little deeper. And I want you to try to get this thing to float somewhere in the middle between the top and the bottom. Now right now it still weighs more, it's going to sink. So I'm going to a little sensitive, but try to play with that to get that to float right in the center. And as you can see on the picture on the right how these things go up and down to adjust their depth in the water. And there's no math or anything that you have to do with that. It's just something to play with. The other simulation I have for you is it's called Buoyancy simulation through Simpop. Now what you have is a vessel, it's like a fish tank. And you have an object, this block of wood in there right now. On the top you can see you can change it from block of wood, to ice, plastic, the brick, aluminum, iron, all kinds of things. At the bottom they have a list of different liquids you can place this object in. Gasoline, oil, water, lead to mercury, liquid metal. And they go, both of these go from least dense to most dense on the right. And take the object, whatever you have at the moment. This is a brick right now. It looks like one. And just drop it in the liquid. And there it sank. It's in what right now? It's in water, I guess. But play around with the different liquids. Play around with the different blocks. And find some interesting differences. And see what happens with the way some things float. Like when you have ice. Let's look at ice and water. We're all familiar with that. When ice is in water, it sticks out of the water just a little bit, like it is in the picture. Well, if you've had mercury in your glass, you wouldn't want to drink it, of course, but just look at, this little, on your own, slide that bottom one over to mercury and see how much the ice floats above the mercury. It's kind of surprising. And also, the block density, aluminum and iron. We've done some work with both aluminum and iron. We have the mass weights for the iron. We have the aluminum blocks we did some labs with. So you're familiar with them a little bit. And you can see when you put those in the mercury, see if they actually float or sink. It'll be a little bit surprising. And there's a table to the right giving you the different numbers as far as what forces there are. So when this ice cube's floating in the water, you can see the net force is 0. And you can play around with the objects to see which things float and sink. All right, the last video will describe the worksheet I have for you.